In this video, we are going to discuss oscillations and wave. Check your understanding, question 7. So let's see what is the question. Question is that there is a small disk of mass m, we can see here. Is that it is attached to one end of the light inextensible cord. So this is the cord which passes through a frictionless hole. This hole they're talking about is frictionless, and the tabletop is also frictionless. So there's no friction anyway. At the other end of the cord is attached a weight of mass m, this mass. Initially, the disk is moving on a circle of radius r with an angular velocity omega. So initially, this is moving with angular velocity omega. If the hanging weight is pulled slightly downward, so this weight, if you pull slightly downward and then release, it will undergo small amplitude oscillations. We have to find the angular frequency. Okay, so I'm going to solve this question from the standard method so that your concepts are clear. So what will be the FBD in equilibrium? This block is moving in circular path, so it is ml omega square. It is given r, but I have taken this as L. Okay, so wherever this r, instead of this r, everywhere I'm going to use L. Okay, fine. So here tension is mr omega square. It is moving in a circular path, uniform circular motion. And if you see this block, then weight is balanced. Weight is balanced by the tension force. So T naught is mg. So that gives us this equation, right? So it's the equation of equilibrium. Now we are going to displace those downward, and we are going to then find out the net force. So let us see now. So now we have displaced it. This distance is x. This is this red color line you are seeing. This is the old equilibrium position. So if the string comes down by x, then here it will be L minus x, right? Its omega is going to change. So let us say new omega is omega prime. Then restoring force on this mass m will be what? Restoring force is the force towards the mean position, right? See here, that will be equal to T minus mg, which is mass into acceleration, right? So what we are going to see here, that if this acceleration comes proportional to the displacement, it is going to be SHM, and we can very easily find out angular frequency. So this T we are going to find out now. To find out this T, I'm going to now see the string, this mass, if it has instantaneous acceleration A, then the entire string, this part also has instantaneous acceleration A, right? One string, the string constraint, and this part also has instantaneous acceleration A. Fine. So now this point is not fixed. So if this point is not fixed, then it will not do circular motion about this point, right? So that's the important thing here. So you have to fix this point first because it is non-inertial point. So I'm fixing this point now. So this point is fixed. Acceleration is A. So if acceleration is A, then when you stand here on the rope, then you will observe this is moving in a circular path, right? So now if I write the equation, it will be T plus ME. Is equal to M L minus X omega prime whole square, right? So T plus ME is equal to MR omega square, the same equation. This is pseudo force part. Okay, so now our last equation is that if you consider this point here, tension is passing through this point, so torque of tension will be 0. So angular momentum of this mass is also conserved, right? So that equation I have written, ml square omega is equal to ml minus x whole square omega prime. So now from these three equations, what I'm going to do now, in this equation, we are going to take tension from here and substitute in that equation, right? Let us see. So MA is equal to ML minus X omega prime square minus MA minus MG. This A I have taken here. And now this omega prime, I'm going to substitute from equation 5. So I got this then, right? After that, since it is written that it is a small oscillations, so I'm using binomial approximation. So when I use binomial approximation, this term and this term cancels, and I get acceleration as 3m omega square x divided by m plus m, right? So acceleration is coming out to be proportional to x. That means it is SHM. Angular frequency is root over this, right? So that's it. That was my analysis. If you have liked this video, like if you've learned something, please hit a like button and please subscribe to this channel also. Thank you very much. I'll see you in another video.